Hey people, welcome back. In today's session, we are going to discuss about standard deviation. So what is standard deviation? Basically, whenever you measure anything, you know the Six Sigma is all about variation reduction. And if it's for the variation reduction, in Six Sigma, in simply we say, if you cannot measure, that means things does not exist. So if you want to reduce the variation, you have to measure the variation. If I say like as if I ask you like as how much is the distance from your home to office? Probably you may say that my distance from home to office is 5 miles. If I ask you what is the temperature now? Probably you will say the temperature is the 30 degrees as of now. If I ask you that what is your height, probably you will say my height is around 180 centimeter. So when you say miles I am using or degrees here in the temperature or the centimeter in the height, what is this? These all are the UOM, which means unit of measurement. Similar way, when somebody asks you that what is the variation in the process? So what will be the answer? How you will answer? How much is the variation in your process? So to represent the variation, the unit of measurement of variation is standard deviation. So in form of standard deviation, we measure the variation. So let us understand what is this standard deviation, because standard deviation plays a very role, very important, very crucial role in Six Sigma, and each and every calculation is based on the standard deviation. So you people must know what is the standard deviation. So what is the standard deviation? Let us understand here step by step. So basically your standard deviation is square root of variance. Now question will come, what is the variance? So the variance, when you calculate, variance is the average value of square deviation. Okay, now another thing, what is the square deviation? So square deviation is just the deviation what you have if you are squaring that, like as square of deviation. Now what is the deviation? Because when we collect the data, we collect the data as an individual value, and then we take the average of that data. So individual value, if you are taking the difference from individual value to the average, so let's say difference of individual value from average value is called your deviation. And you already know what is the average. Average means you are taking the sum of all values, and if you divide this by the count of all value, then you will get the average. So this is the way manually we calculate the standard deviation, or these are the steps to find out how much is the variation in your process in the form of standard deviation. Let's take an example. Simple example we'll take. Suppose here is the time to office, and you are telling that boss, I will reach in office maybe around 30 minutes. When you use the word around 30 minutes, that means there is a some plus minus may happen here. And you collect your time, maybe we see the last 30 days of data or 25 days of data, that when you say around 30 minutes, so maybe you are reaching from 25 minutes to 35 minutes, which is on an average, maybe nearly 30 minutes you are reaching, but there is a variation involved here. If somebody asks you that how much is the variation in your time to reach office based on the last 30 days, So how you will define it? Now you need to calculate the standard deviation of this data. So here your time to office is given. So how to calculate the time to office standard deviation? So this is the first value, which is your individual value. This is represented by xith value. Example, this is your xi1, this is your xi2, xi3, and so on. You have these value collected for the last 30 days. This is the individual value represented as an xith value. Now the next thing, I need to find out the average of this, because deviation I can get only when I see the difference of individual value to the average value. So here I will write average. Using the Excel formula, I can get the average very easily. And here we go. So this value is your average time which you are taking to reach office is around 30.4 minutes as per this calculation. This value I will copy and paste against each of the value. Right click here and paste as in value, because otherwise formula will be copied. Now when I pasting as in value, I can easily find out the difference from individual value to the average value. So average value in statistics represented by the X bar. And when you see the difference means it is the deviation. Deviation is your Xi minus X bar. Xi value is this individual value and X bar is your average value. Now deviation will be first value Xi is 31 minus X bar 30.4, then 30 minus 30.4, then 33 minus 30.4, 30 minus 30.4, like this and so on. And this formula I am copying till bottom and we got all the deviation. You will notice one thing, some values are positive here and some values are negative here. Why? Because average is your center value. So when you are calculating the average, picking up the center value, definitely some value will be less than the center value and some value will be more than the center value, because how you are making a distribution of the data, assume your distribution of the data will go like this. And you found that there is a center value here. So values which is less than this center value or the average are negative, and values which is more than the center value or the average right side, they are positive. Because average is the center value, which means whatever the deviation you are getting, if you take the sum of all deviation, that must be 0. Why? Because values are equally distributed. So if I see here, you can see count is 30, average is 1.42 of the deviation, and the sum of the value is 0. Let's calculate here, alt equal, and I convert this into the numbers, and you will see value will be, should come 0. You can see 0, which means I calculated deviation correctly. Why I am doing this? Though Excel will definitely calculate all these value correctly, but before, when the Excel, MS Office or software was not there, so people used to calculate manually, and then they used to verify, okay, what is the, either I have calculated the deviation correctly or not. Now once you calculated the deviation, because standard deviation cannot be negative, variation cannot be negative variation, you understand that it has to be more than 0 or 0. 0 is when all the values are consistent. It will be non-zero when there is a difference in at least one of the single value. I will give you that example as well. Okay, let's understand that only. Suppose you have the data. Data here says maybe you are taking 20 minutes today, 20, 20, 20, 20. You have this around 6 days of data. And if you want to find out what is the average of this value, average of this value will be 20. Because all the value are consistent, so 20 on an average, and you look for the variation in this value, which is in the form of standard deviation. So standard deviation will be 0. Why? Because all the values are consistent. That's how you got the standard deviation 0. In the similar case, if I pick up this data here and I change this value to 22, and this value to 18, this value as in 19, this value as in 21, this value is, let's say, 21, and this value is 19. If I look for the average of this data, it is still 20. But the standard deviation of this data, because the variability is there, this has moved to 1.41. Why? Because I do not have the consistency in the second data set, which is available in the first data set. So when all the values are same, they are consistent, variation or standard deviation will be 0. In case any value differs, because of that difference, my variation will be greater than 0. So that's how your standard deviation cannot be 0 in case there is any value difference, and it has to be greater than 0, and it is always positive. So you have all these. Sometime you are getting negative value, which is in the red color. Some values are positive, which is in the blue color. So what I will do, I need to neutralize the impact of negative and positive on each other. So for that, I am going to get squared deviation, which means I will be squaring the deviation what I have here. What I'll do is equal to selecting this value, simply power 2, which means I am doing the square, and here we go. I copy paste this formula till bottom, and I got my squared deviation, all values. Square deviation I got. What is the next step? Square deviation when I get, next is variance. Variance is the average of your square deviation. So if I get the variance here, variance, I am going to get average of square deviation. So is equal to average. And here is the square deviation. If I take this, I will get my variance value, which is 7.44 is the variance in my data. Now the next thing is to find the standard deviation. So standard deviation, if you see here, is the square root of variance. So if I take square root of this value, I'll get my variance value. Sorry, square root of variance, I will get my standard deviation. Done. This is the way standard deviation is calculated manually. Because we are in the advanced generation, we have so many softwares, have an Excel. So all these things comes with the Excel inbuilt formula. You need not to worry about to going for the such lengthy calculation. Simply you put a formula here in the variance var dot p, selecting your numbers, and you will get the variance here. 7.44, you got with the formula var dot p, selected this number. Similar way, you can just get the standard deviation as an stdev dot p, selecting these numbers, and you will get the standard deviation as well, which is 2.73, approximately what we got in the manual calculation. Again, want to show the formula. Formula is here. So that's the way we get the standard deviation, and this is the unit of measurement of variation. Very, very critical component of standard Six Sigma, and very critical concept as well to calculate the sigma level of the process. It's important. When I will cover in the next topics how to calculate sigma level of any process, then you will see how important standard deviation is. So till the time, bye bye, take care. I will see you soon. Thank you so much.